All right, so we're looking at 4.2, and 4.2 is about estimating the slope of a tangent line to a curve. And we have actually talked about this before, so we're going to do this as an example. So we have a function y equals x squared minus 1. It's this purple parabola that opens up. It has a y-intercept of -1. And we want to talk about the point P right here that has the coordinate of, of 2, 3. So that is a point on my parabola. And we talked about this before, saying, well, I could use a secant line. And the advantage of using a secant line is that it's going to touch my parabola in 2 points. So I could take a point out here, I could take a point down here somewhere, and I could find the slope of that line just by using our slope formula. So, not y. M equals y1 minus y2 over x1 minus x2. So we could use the slope formula to estimate the slope, and the idea is that as we let these points get closer and closer and closer to my point 2, 3, the slope is going to be really, really close to the slope of the tangent line. And if we use limits and we get it so close that it essentially becomes 1 point, what we actually do is we find the derivative. And what's the derivative again, Adam? The slope of the tangent line. So keep that in mind, and we are going to go through and do this estimate. So a way for me to do that is to use my point 2, 3, the actual point where I want to know the slope of the tangent line, and I'm going to take a second point like 3, 8, which is on that secant line, and I can calculate the slope, and I get a slope of 5 if I use the slope formula. Well, 3, 8 is still a fair ways away from 2, 3, so I'll keep getting closer, and I could pick another point that's even closer, 2.5 and 5.25, and then I get a slope of 4.5. And if I went and got even closer, 2.1 and 3.41, and it's kind of messed up here, but you would get a slope of, I think it's 4.1. And really, 2.1 and 3.41 as 1 point and 2, 3 is my other point. They're getting pretty close together. So if I keep going even closer, I'm going to erase this and check out my fourth point. Well, now I'm only 1/100th away from my x value and 4/100ths away. And essentially, if I round it, I'm going to get a slope of 4. And because that's where my number was heading, see, I went from 5 to 4.5 to 4.1 to 4, we would say that sort of the limit as I approach 2, 3 is equal to 4. So we would say that 4 is the slope of the tangent line. Yay! Well, another way for me to think of that 4 is that the derivative of my function x squared minus 1 at the point 2, 3 has a derivative of 4. So the slope of the tangent line at 2, 3 on my parabola is 4. So that is one way that we could estimate.